Hello, this is Jacob out. This video is going to be for the purpose of giving you an update on my full auto coil gun project. I'm going to show you the circuit design that I came up with and explain to you how it works, and I also have mapped out on a solderless breadboard a test version of the circuit so that you can see the circuit actually working, and it will hopefully only be that's October 16th or October 17th, have a video for you of the first test shots from this coil gun, and within a few weeks from now, maybe a month, hopefully the thing will be actually fully completed and shooting full auto. This is the circuit that I have designed to use with the full auto coil gun project. This is the circuit set up on a solderless breadboard. The only differences from the main circuit are that for the load, instead of the coils for a coil gun, I have an LED with a resistor. This wire sticking up into the air right here is the trigger wire, and these two are the light gate. This is the infrared LED and this is the infrared phototransistor, aimed at each other with a gap between them. Between each one of them is this orange thing, and we have glued in an infrared LED and a phototransistor, so there's a light gate after each coil. To initiate it, what you have to do is just give a quick plus 5 volt signal, can be very short, to this trigger wire, which is what this other wire, this is just coming out of the plus 5 volt rail. So just that quick tap and it's on and stays on, because it's part of the circuit that once the load is powered on, that also powers on the light gate, which keeps the signal coming to keep the load powered on. So that's like a positive feedback loop between the signal that's going to the load and the signal that's coming from the light gate. But if I cut off the light gate, even just for a quick moment, it stops the cycle, so that once the projectile passes a light gate in the barrel, turns off the coil right behind that light gate. So all the coils behind it turn off. So at the beginning of the barrel, the projectile rests against the position sensor for the projectile, and all the coils come on. Then passes the end of a coil, and just with a very short cutoff of the light across the light gate, shuts off the load. The coil is shut off. The circuit is repeated for each coil. Basically, it's the main power going through the coil and to ground, but it goes through a MOSFET, and all this stuff up here is just for controlling the signal to the power MOSFET to tell the coil when to be off and on. This part here represents the light gate. So a positive signal is applied when the projectile is at the base of the barrel, ready to be fired. An entry part of the barrel, kind of a chamber, will be back here, made of plastic, and a little switch. So when the projectile is loaded forward, it kind of pushes the switch off to the side, and that switch triggers the trigger wire. Okay, the plus 5 volts wire that starts the whole cycle, turns it on. Once that happens, all of the coils come on. So it's drawn forward, and as it crosses each gate, the coil immediately behind that gate turns off. A positive signal is applied when the projectile is at the base of the barrel, ready to be fired, which goes up here, turns on this transistor. The plus 5 volt signal flows through this transistor, which just got turned on, and this is only for a brief instant, but it turns it on, the signal comes over, turns on this transistor as well by coming to the base of that, lets 5 volt come in through here, and the 5 volt coming in through there goes on and turns on the main power transistor, and it also turns on this infrared LED, which shines a light across the light gate onto this phototransistor, which allows the current to continue flowing to turn on this transistor. And this is the transistor which decides that the LED and the main power MOSFET for the coil are on. So as long as the light keeps shining across here, once you get this quick pulse, the light turns on, even if it's like a millisecond or something. There was probably a minimum amount of time that it has to be, but it's an extremely short amount of time. So the light comes on, keeps shining across, and keeps letting the voltage come, telling the light to stay on and shine across, and also keeps letting the voltage come to the gate pin on the MOSFET to keep the coil on. And of course this part in the red box represents the coil on the coil gun, for one stage. But once the projectile comes through the light gate, it casts a very short shadow, but it's enough to where the plus voltage is no longer coming through the phototransistor for a moment, which turns off this transistor also. And when this transistor is turned off, turns off the light, so the phototransistor stays off once it stops getting light just for an instant. And when this transistor is off, because of all that, it also cuts off the voltage to the MOSFET, so that's just getting the ground signal through the resistor, of course, and turns off the coil. And the current in the coil wants to keep flowing the same way, but since it can't because this is cut off, it now just has to flow through this, and pretty quickly will drain most of its energy to heat in this resistor and in the diode. So I was originally, I don't know if you've seen the other video, I'll put a link to it on the screen, but I guess I'll put one of these cards up here. That's what I'll do, one card. So what that other video that the link is to shows is it's going to be 3 coils on, so 3, 3, 3, a wave rolling forward. But to simplify it, and to where I'll actually get it done without having to mess with microcontrollers or something that I don't want to have to deal with, I'm just going to have it so all of the barrels, or all of the coils come on, touches the switch. The switch allows the coils to come on by sending the signal. The switch basically does that. Then, as soon as it comes up here, comes to the light gate, and that's basically the same as putting a shadow between the LED and the phototransistor. So that turns off this first coil, comes to the next one, turns off this coil. Comes to the next one, turns off this coil. So that way, as soon as it crosses a coil, it turns it off. And it's still, the center of the magnetic field is way ahead of it the whole time. It's drawn to the center of the magnetic field. So even though it crosses the halfway point of one coil, that doesn't matter. It's still being drawn forward until it reaches the center of the magnetic field. And then when you get to the very last one, when it crosses this, both of the last 2 coils are shut off at once. That's why I call it 18-stage coil gun, even though it's 19 coils. Thank you for watching. I hope you enjoyed the video. Please subscribe to this channel if you'd like to see more of the videos that I'm making, or just to be nice. Thank you. Bye.